Alright, let's look at the theorem for general solutions of homogeneous equations. Alright, so let's say you have an nth order homogeneous linear equations, and we happen to have n linearly independent solutions. Alright, then every solution of this differential equation can be written as the linear combination of those n solutions, right? So let's look at this following example. We have third order homogeneous linear equations, and with the initial conditions given there. And let's say we already have linearly independent solutions, and y1 is e to the x, y2 is e to the 2x, and y3 is e to the 3x. Right? So according to the theorem, any solution that we are looking for can be written as y equals c1 e to the x plus c2 e to the 2x plus c3 e to the 3x. Alright, so we just have to find c1, c2, and the c3 value using the initial value conditions. Alright, so let's use the first one. Alright, so this will tell us y of 0. Alright, if you plug in 0, you're going to get e to the 0 is 1, so you're going to get c1 plus c2 plus c3, and this has to be equal to 0. So we got one condition, and if you take the derivative of y, we'll get c1 derivative of e to the x is e to the x, and derivative of e to the 2x is 2 e to the 2x, and derivative of e to the 3x is 3 e to the 3x. Right? So if you plug in x equals 0 into y prime, we'll get c1 plus 2c2 plus 3c3 is equal to 0 again. Right? So we know that that's going to be equal to 0. Right? Then we take another derivative, y double prime. Right? Derivative of c1 e to the x is again c1 e to the x. And derivative of that would be 2 times 2, 4 c2 e to the 2x. And plus derivative of that is 3 times 3, 9 c3 e to the 3x. Right? Then if you plug in x equals 0 into that, you're going to get c1 plus 4c2 plus 9c3. Right? And this is going to be equal to, in this case, it's positive 3. So positive 3. Right? So we need to find the c1, c2, c3 value from there. Alright, so I'm going to use these two. Let's look at these two guys. And I'm going to subtract the first equation from the second equation. So you're going to get, let's see, so c1 minus c1 is 0. 2c2 minus c2 would be c2 from here. And let's see, 3c3 minus c3 would be 2c3, and that's going to be equal to 0, right? And then I'm going to probably combine these two guys together, so second and the third. So I'm going to subtract the second equation from the third equation. Again, c1's cancel out. So 4c2 minus 2c2 would be 2c2, right? And 9c3 minus 3c3 would be 6c3, right? And then 3 minus 0 is going to be equal to 3, right? then I'm going to multiply this equation by 2 to get the 2c2 plus 4c3 is equal to 0. So I'm going to go through the subtraction. Then we get, let's see, 6c3 minus 4c3 would be 2c3, and that's equal to 3. So divide through by 2. We have c3 is equal to 3 halves. All right. So once you've done that, then we can find c3. So I'm going to plug this value back into, say, this one right here. All right. Then you have, you're going to get the c2. All right. 2 times 3 halves is just going to be 3 is equal to 0. So we can simply subtract 3. C2 is going to be equal to negative 3. All right. So since we have a C2 and a C3, I'm going to plug those guys into the first equation. So you have a C1 plus C2. C2 came out to be negative 3. Right? And the C3 came out to be 3 halves. And then this is equal to 0. Right? So if you simplify that, C1, right, minus 3 is minus 6 over 2, so it's going to be negative 3 over 2 is equal to 0. So we can add 3 halves to both sides. C1 is equal to 3 halves. Right? So therefore, we have a solution. Y is equal to, right, C1 is 3 halves e to the x. Right, C2 is negative 3 e to the 2x. And then C3 is positive 3 over 2 e to the 3x. Right? So that's the solution of the initial value problem given here. Right? That's it. I hope that this was clear.